Rooftop solar panels are appearing on homes across the globe. Their popularity stems from a desire for clean energy. Homeowners are drawn to generating their own power. Solar offers independence from traditional energy grids. The shift towards solar signifies a changing world. People are becoming more aware of their environmental impact. They seek ways to reduce their carbon footprint. Solar energy presents a tangible solution. This embrace of solar must be tempered with understanding. While the benefits are clear, there are hidden costs. The full environmental impact must be considered. We must approach this new technology with open eyes. Only then can we harness the power of the sun responsibly. Solar panels offer homeowners significant financial benefits. Electricity bills shrink, sometimes dramatically. The initial investment is offset by long-term savings. This financial incentive is a major driver of solar adoption. Beyond personal savings, solar energy benefits the environment. Unlike fossil fuels, solar panels produce no emissions during operation. They tap into a clean, renewable energy source, the sun. This shift away from fossil fuels is crucial in combating climate change. The environmental advantages extend further. Solar panels reduce our reliance on centralized power plants. These plants, often fueled by coal or natural gas, contribute significantly to air pollution. Solar energy offers a cleaner alternative, improving air quality and public health. While these benefits are undeniable, a complete picture requires scrutiny. The production and disposal of solar panels present their own environmental challenges. These challenges must be addressed to ensure a truly sustainable solar future. The manufacturing of solar panels, though often touted as green, is a complex process. It requires significant energy and resources. Raw materials, including silicon, silver, and copper, must be extracted and processed. Mining operations can have detrimental environmental impacts. Deforestation, habitat loss, and water pollution are potential consequences. The extraction and processing of raw materials also generate greenhouse gas emissions. Transportation of materials adds another layer of complexity. The globalized nature of solar panel manufacturing means materials travel long distances. This transportation network relies heavily on fossil fuels, contributing further to emissions. These environmental costs are often overlooked. We must acknowledge them to make informed decisions about solar energy. A truly sustainable future requires minimizing the environmental impact of every step in the solar panel lifecycle. Solar panels have a finite lifespan. After 25 to 30 years, their efficiency declines. They eventually become electronic waste, requiring proper disposal. This presents a growing challenge as the number of retired solar panels is rapidly increasing. Existing recycling infrastructure is ill-equipped to handle this influx. Solar panels are bulky and difficult to dismantle. Specialized facilities are needed to safely extract valuable materials and dispose of hazardous components. The lack of adequate recycling options raises concerns. Improper disposal of solar panels can lead to environmental contamination. Toxic materials, if not managed correctly, can leach into the soil and water, posing risks to human health and ecosystems. Addressing this waste problem is crucial. Investing in recycling technologies and infrastructure is essential. Developing sustainable end-of-life solutions for solar panels is vital for a truly circular economy. Section 5. Toxic components and recycling challenges. Solar panels contain a variety of materials, some of which pose environmental and health risks. Certain types of solar cells use cadmium telluride or copper indium gallium selenide, both containing toxic elements. These toxic materials, if not handled properly during recycling, can contaminate the environment. They can leach into groundwater, posing risks to human health and wildlife. Safe handling and specialized recycling processes are essential. The recycling process itself presents challenges. Solar panels are constructed with layers of different materials, making disassembly complex. Separating these materials efficiently and safely requires advanced technologies and infrastructure. Current recycling methods often fail to recover all valuable materials. This limits the economic viability of solar panel recycling. Research and development of new, more efficient recycling technologies are crucial to address this challenge. Section 6. Advancing towards sustainable solar. Despite these challenges, the future of solar energy remains bright. Technological advancements are paving the way for more sustainable solar panels, from production to disposal. These innovations offer hope for a truly green energy future. Researchers are exploring new materials to replace toxic components. Organic solar cells made from carbon-based materials offer a promising alternative. They are less toxic and easier to recycle than traditional silicon-based panels. Improving recycling technologies is another key area of focus. New methods are being developed to more efficiently separate and recover valuable materials from solar panels. These advancements will improve the economics of recycling and reduce waste. The goal is to create a circular economy for solar panels. Materials would be continuously reused and recycled, minimizing waste and environmental impact. This requires collaboration between scientists, manufacturers, and policymakers. Section 7. Second life for solar panels. While recycling is crucial, extending the lifespan of solar panels can further reduce waste. Retired panels, even with reduced efficiency, can find a second life in various applications. This approach maximizes resource utilization and minimizes environmental impact. One option is repurposing retired panels for off-grid systems. They can provide power for remote homes, farms, or communities without access to reliable electricity grids. This can improve living standards and promote economic development in underserved areas. Another potential use is in developing countries with growing energy demands. Retired panels from developed nations can be deployed in these regions, providing affordable access to clean energy and supporting sustainable development. By exploring these second life options, we can maximize the value of solar panels beyond their initial use. This circular economy approach minimizes waste and extends the benefits of solar energy to a wider population. Section 8. A balanced perspective on solar energy. Solar energy offers tremendous potential for a sustainable future. It provides clean, renewable electricity, reducing our reliance on fossil fuels. However, it is not a silver bullet. We must address the environmental challenges of production and disposal. A balanced perspective is crucial. Transparency and responsible practices are essential. Investing in research and development is key. We need sustainable end-of-life solutions. This ensures solar energy's promise of a clean future. Section 9. Our shared solar future. The journey towards a sustainable energy future requires collective effort. Scientists, policymakers, manufacturers, and consumers must work together to overcome the challenges and unlock the full potential of solar energy. Governments play a crucial role in setting standards, providing incentives, and supporting research and development. Manufacturers must prioritize sustainable practices throughout the supply chain, from material sourcing to product design. Consumers have a responsibility to make informed choices. Understanding the environmental impact of solar panels empowers us to demand transparency and support companies committed to sustainability. We are all stakeholders in this endeavor. By working together, we can create a future powered by the sun, a future where clean energy is accessible to all, and where our planet thrives for generations to come.